எல்லாருக்கும் வணக்கம். என் பேர் மனோகர். I am the founder and founder of this company, GreenRoboMac. More important, நான் ஒரு விவசாயி. நான் திருவாரூர் டிஸ்ட்ரிக்ட், தமிழ்நாடு திருவாரூர் டிஸ்ட்ரிக்ட் நனிலத்தில் அதம்பா ஒரு வில்லேஜில் விவசாயம் பண்ணிட்டு இருக்கேன். எனக்கு ஒரு 12 ஏக்கர் நிலம் இருக்கு. பேடி நெல்லும் பருத்தியும் பண்ணிட்டு இருக்கோம். ஸோ most of what I am doing is based on what my own experience. So இன்னைக்கு என்ன பண்ண போறோம்னா, we are going to talk about solutions for mechanization solutions for higher productivity and sustainable farming. Let's go into the details. So இப்போ farming cycle பார்த்தீங்கன்னா seedingல இருந்து harvesting வரைக்கும் lot of tasks are there. இது நீங்க ஹார்டிகல்ச்சர் பார்த்தீங்கன்னா இதெல்லாம் முக்கியமான ஒரு டாஸ்க். நெல் அப்படின்னு பார்த்தீங்கன்னா சில டாஸ்க்லாம் இருக்காது. இது ஒரு ஜென்ரலைஸ் திங். இப்போ நம்ம விவசாயத்துல பார்த்தீங்கன்னா மெக்கனைசேஷன் பார்த்தா டிராக்டர் இஸ் a வெரி குட் சொல்யூஷன். நிச்சயமா மாடு ரீப்ளேஸ் ஆயிடுச்சு. பட் மற்ற எல்லா வேலையும் மனுஷங்க தான் இன்னும் பண்ணிட்டு இருக்காங்க. லாட் ஆஃப் டாஸ்க். பட் crops like paddy is largely mechanized. பட் நீங்க ஹார்டிகல்ச்சர் காட்டன்லாம் பார்த்தீங்கன்னா இன்னும் இட்ஸ் a long way to go. ஸோ முக்கியமான பிரச்சனை என்னன்னா, இப்போதைக்கு விவசாயின்னு பார்க்கும்போது பீக் டைம் லேபர் டிமாண்ட் இஸ் தி ஃபண்டமெண்டல் இஷ்யூ. அதனாலதான் நிறைய பிரச்சனை விவசாயிக்குன்னு வர பிரச்சனை. முக்கியமானது பீக் டைம் லேபர் which is related, which triggers multiple things. One of the thing is சரியான நேரத்துல பூச்சி பாதுகாப்பு பண்ண முடியல, சரியான நேரத்துல நீர் வேளாண்மை பண்ண முடியல, சரியான நேரத்துல அறுவடை பண்ண முடியல. இதனாலதான் yield and productivity is low. Yield is also an issue, and farmers don't get a good price or economics. So what I am doing is நான் harvesting முக்கியமா பார்க்குறேன். பருத்தியில harvesting பார்க்குறேன். ஏன்னா that is the most important task in பருத்தி. But we'll go to the other things. In the slide I have given a lot of other reasons. But so mechanization is a good solution. World over this is a problem. Indiaல மட்டும் இல்ல, world over Western nations have solved it to some, are solving it to some extent, and they are ahead of us in trying to solve it. But they are not very far away. I think we as a country can adopt, buck up and do a lot of things and bring up a lot of good solutions to the world as well as for our own Indian farming conditions. So பார்த்தீங்கன்னா, I'm just giving some few examples of what's happening in the world. It's not that commercial நிறைய solution வந்துட்டு இருக்கு, but not very many. இது I started my journey in mechanization or robotics in farming in 2014. அதுலேருந்து ட்ராக் பண்ணிட்டு இருக்கேன். இப்போ பார்த்தீங்கன்னா ப்ளூ ரிவர் டெக்னாலஜி லெட்யூஸ் தின்னர் அப்படின்னு ஒன்று இருக்கு. பேசிக்லி தின்னிங் ஆப்ரேஷன் இட் சால்வ்ஸ் த தின்னிங் ஆப்ரேஷன். இட்ஸ் அ வெரி லேபர் இன்டென்சிவ் ஜாப். இது தின்னிங் ஆப்ரேஷன் ஒரு குழியில மல்டிபிள் விதை போட்டுருவோம். ஃபைனலி ஃபார் அ குட் ஈல்ட் நம்ம ஒரே ஒரு செடியை தான் அங்கே விடணும் அப்படின்னா, பட் டு கிவ் த பாப்புலேஷன் டென்சிட்டி கரெக்ட் அண்ட் ஃபார் ஆல் அதர் ரீசன்ஸ். ஆஸ் ஸ்டூடெண்ட்ஸ் ஆஃப் அக்ரிகல்ச்சர் யூ ஆல் நோ வாட் இஸ் தின்னிங், அண்ட் திஸ் இஸ் ஒன் இம்பார்ட்டன்ட் திங், பட் not many people do it. But in US, lettuce is such a delicacy and quality crop, and you don't have a good crop, people don't buy it. And this company called Blue River completely mechanized it. Inge left bottom la pathina harvest automation. This nursery robots, this has been there for quite some time. The machines around $15,000, $10,000 to $15,000 in different combinations. You can actually go and see what they do in the videos, online videos. They nursery in pathina, that's one of the most labor intensive tasks in agriculture, to manage a nursery. So they have really mechanized a lot of things. Right side on the yellow color machine sweeper is one of the emerging solutions for capsicum harvesting. It came out of an university, and now it has been built as a product by the European Union. And இதே மாதிரி நிறைய இருக்கு இந்தியாவில் பார்த்தீங்கன்னா எங்களோட company is trying to do harvesting of cotton. There are very few other companies like Tata and Sons trying to do weeding. இதே மாதிரி 2-3 company இருக்கு, but not very many in Indian. But there's nothing stopping us from doing it. There is huge demand for mechanization, specifically precision mechanization. We can call that as a robotics, but there's nothing technology. It's not a rocket science. There is a lot of things. It's available as a technology. We can go and build it, but there are a lot of challenges. I'll go through some of them in this thing. So for cotton farming, I just want a little bit on cotton farming. I am focusing on harvesting. Why? Because I was doing my cotton potta, very good yield of cotton bottom, but I didn't get people to harvest. Over 2 months, I lost the whole crop. So I took it on myself to mechanize it. But that is one of the most critical tasks. But all over the country, we have the same problem. People are not available. And though we are one of the largest nation producing cotton, our average yield is very, very low. Our cost of production also is going up. We own 12 million hectares of cotton, which is 1/3 of the world's cotton production land under cotton, right? Cotton, all the tasks here are listed are important, but most of us don't even do much of it in the right time. Most of the problems in yield on a good quality crop are related to doing these tasks at the right time, at the right precision. So mechanization with some precision is what really matters for us, right? Actually, for as a side note, if you look at it, cotton, all of us know in India it's one of the as a fiber, it's one of the largest fiber used. 80% of Indian garments are using cotton. But world over, only 20% of the cotton is used as a fiber. Everything is synthetic. So there's a huge opportunity for even cotton. I'm more attracted to the cotton farming for very many reasons. But one of that is to say that cotton is actually a good crop for the farmers, especially in the land where there's a lot of sunlight and there's no water. So I'll go into each one of this task and highlight what is to be done and why and where we are now. Seeding, everybody knows that transplant is the best mechanism. But நீங்க பாத்தீங்கன்னா நெல்லுல நம்ம டிரான்ஸ்பிளான்ட் தான் பண்ணிட்டு இருக்கோம். 2 காலமா நெல்லு இப்பதான் வந்து டைரக்ட் சீடிங் அதெல்லாம் போயிருக்கோம். But it's not the transplant is the best method. But why we can't do it? Horticulture பாத்தீங்கன்னா it's the best way to do it. But why we cannot adopt it is because there's not enough labor available, and it's a very, very precision task. So mechanizing that is really, really a great opportunity for every aspect of the crop economics, as crop productivity and good yield and less pests and diseases also, right? So cotton la panna mudiyuma appadina it's really a research topic. Some of the faculty of TNU has done experiments, and maybe we can mechanize it. I'll just go into the next one. Weeding, all of us know mechanical weeding the best method appadina. Ipa neenga pathina, including me, I use only chemical weeding simply because there is no people to do it. Can I mechanize it? Yes, we can. There are a lot of people working towards this. And why we don't have a solution in the farm today is because of the cost. The cost of the weeding solutions today we have now is really, really not an affordable solution for many of the farmers. Maybe it is good for the large farmers, but still not good for us small farmers. And the weeding solution has to be customized for different crops, right? And வாழைத்தோட்டத்துல weed பண்றது different from நெல் வயல்ல weed பண்றது is very different. And similarly the cotton. So you need to have different solutions for even weeding. And I don't want to talk about pruning. Pruning has to be done in most of the orchards, but we don't have good solutions. You look at spraying, 80% of the spraying we are doing is a wasted chemical today. And that's a known fact. It's been published, but we don't have a good solution. We need what is called as precision sprayers and what called variable rate spraying. And is this technology available? Yes. Why is it not commercially available? There are quite a few challenges. Most of that are related to how robust and reliable and how cost effective are these solutions in the field, right? We have solutions like what we call as for improving the performance of spraying. We have drone-based spraying, but I don't think that's going to be the best solution from the effectiveness of a spraying. But that's one good step going forward. So topping is an important practice in many of the crop, definitely in cotton. Cottonla வந்து 21 branch வந்தோன்னா we have to top the plant so that it stops growing vegetatively and grows into a reproductive phase. It has been proven to give a lot more yield. There are publications saying that it gives 30% yield. I have seen some 15 to 20% yield improvement in my own farm. But why don't we do it? Just that we don't have people to do it. Topping is nothing that may top branch வந்து கட் பண்ணி விடணும், அவ்வளவுதான். That is all it is. Why can't we do it? This is required even in tobacco. So this is an important task, but none of us do it, and no farmer is even willing to do it for very, very many reasons. There is a cultural reason also. Every farmer thinks that green is better, but in cotton that is not the case. So harvesting, picking, that is clearly the reason I am started this company, because we don't have enough people. Picking is a very, very precision task. It requires a lot of intelligence. We need to know which to pick. இப்போ போய் பார்த்தீங்கன்னா people for various reasons even pick the moist cotton, which is really, really bad for the whole ecosystem. Moist cotton will spoil the whole rest of the cotton also because of fungus. But how do we, and it is a very, very drudgery job where Nadu, you have to pick one by one, and the way you can't really do that job. Given an option, people don't want to come and do that. So can I mechanize it? It's one of the technologically difficult problem, though I am pick that task and trying to build that as a solution. It's a very high precision task. Cotton is a precision. If you look at other crops like do you want to harvest brinjal, lady's finger, அது மாதிரிலாம் பார்த்தீங்கன்னா இன்னும் it will become a lot more challenging than even cotton, right? It is the technology is there? Yes. Overall, I think there is technologies. There are companies doing only apple harvesters. There are 3 companies doing only apple harvesters. None of them are at commercial. There are companies doing only strawberry pickers. There are companies doing only pomegranate harvesting machines, and a whole lot of them. And each one of them has its own challenge. But the overall technology is definitely in a simple and coming into a common technology. And what we have as a solution for cotton is a machine. We call it as Pragati. It has 3 parts to it. One is Yanthra. It's a robotic arm. I'll go into a little bit detail of that. From Mark, we call the vehicle as the Mark. It's a acronym. And Vistar is a software which runs behind this. Yanthra is a completely I have been focusing on picking. It does exactly the job of a human picking. It's completely autonomous in the sense நம்ம கண்ணு கை எப்படி வேலை பண்ணுமோ அதே தான் Yanthra is doing it. But it also has a vacuum to take the cotton out of the plant and throw it into a bin. So this I spent quite some time on this thing. It's been my own passion of doing this. This is the mission we have now. I'm testing this in Manilam now in my own field. In நீங்க பார்க்கிறது வந்து 2-arm mission. It's a very compact 3 feet roll வந்து போகும். As I said, picking one is completely mechanized. There is absolutely no human intervention for this. It's autonomous. என்ன சின்ன நார்மல் ஃபார்முக்கு போகலாம். யூனிக் செல்லிங் பாயிண்ட் என்ன வித்தியாசம் அப்படின்னா, we can pick multiple times just like humans. ஒரு செடியை வந்து டேமேஜ் பண்ணாம we can pick cotton multiple times. It's what cotton is called multi-bloom, and we can pick multiple times. John Deere அப்படிங்கிற machine வந்து is a very well proven machine in the West for large farms, but they do what is called as a synchronous bloom, or ஒரே ஒரு டைப் தான் பிக் பண்ண முடியும். So that is what differentiates us from John Deere. We are targeting the Indian kind of farming conditions. அந்த John Deere அப்படி வரணும் அப்படின்னா we need two more task requirement. That is, one is defoliant, இலைய உதறதுக்கு defoliant வேணும். அப்புறம் அந்த ப்ளூம்லாம் சிங்க்ரனஸாக ப்ளூம் பண்ணுறதுக்கு we need what is called the PGR, plant growth regulator. That's not really an option for a current generation of the Indian farmers, especially the small farmers. So we need to find a solution for them now, and that's what I'm doing. So this mission does not require any change in agronomy practices. We are targeting to pick 50 kgs per day, 10 hours day. That's about 1 cotton in 2 seconds, right? We can also pick in low light or even in the night, though we are not yet proven it in the night. The technology we use is called 3D vision AI, basically AI in 3D, right? For detecting and locating the objects. நம்ம கண் பார்க்கறது, கண்ணு மூளை செய்யற வேலை வந்து we are doing it what it calls 3D vision AI, and then கை பண்றது whatever we are doing the arm, we have a robotic arm, and we transfer the cotton using airflow vacuum. So this is a single person operated machine, electrically operated mission. Video on the you can see it here, and there are a lot more videos about this technology in the website I have given here. As a higher technology, what is it? It has a 3D arm, has a 3D camera, and with the camera we can detect anything. We are detecting cotton. We can detect any other object. Capsicum and bendi, brinjal. Then we have a high-end. I wouldn't call it really high-end. A single board computer, which controls the whole system. It takes the images, it detects and locates the object, and then controls the arm to go and pick it. So this is what we have is what is called a 3 degrees of freedom arm, what you call as a telescopic arm for that's good enough for a cotton. And then we have a specialized actuator. You should go and see the video how exactly it works, and it actuates the picking unit, and then it transports the cotton. This is the overall technology. There's a lot of details into this, which involves a lot of mechanical engineering, a lot of software and vision engineering, and of course the latest AI aspects of it. So there are a lot of challenges, right? in anything in agriculture, we can build a robot which can run in a factory, and there are huge challenges there. But you bring the same solution into a field, an open ended field, you have a huge different challenge, right? First and foremost is the reliability and robustness. We have to be running continuously in open sunlight, light and different lighting conditions and temperature and dust conditions. So the reliability is really the biggest challenge we have to build it as a commercial product, right? The other important thing is we cannot assume a lot of facilities like in a factory, right? We don't have power. You can't assume power. You can't even assume there's a network available in the field. You can't do what is called as cloud-based computing, right? I had to do everything on the edge, right? And we had to build the hardware such that you don't need a huge infrastructure to support it. If you take a tiller or belt, you have to really worry about it, right? A farmer, Gramatla, tiller or a belt, he is off by half day, right? So I can't have technologies very difficult to replace or maintain. So a maintenance of this big robo has to be really good. Yeah, I call it robo, but remember that every farm equipment will have a person behind it. So if you're building a solution, assume that there is a human there. You don't have to build it very intelligent. You don't have to build an autonomous everything. It is trying, what we are trying to address is trying to minimize the number of labor we really require in the farm, not totally take away the labor. So you have to utilize, put some intelligence, take the intelligence of the operator and try to utilize in some ways, right? In our mission, we try to make the mission run in a straight line, but when you want to turn it around, we use the operator. We don't want to add complexity to the mission and increase the cost. Of course, the final thing is the cost, right? We can build animation at whatever cost you can, but it cannot be usable by the farmer if you don't bring it to the right cost. Cotton பார்த்தீங்கன்னா ஒரு 1 kg pick பண்றதுக்கு 10 to 12 rupees ஆகுது ஒரு kg. If I don't do a machine which targets that cost, then obviously my machine is not going to be anyway commercial. So if you want to make it commercial, it will be more of an academic operation. So that is one of the important things. When I started my building this solution, it was costing around 2 lakhs to 3 lakhs to build one arm. Today we are at around 80,000. We have simplified a whole lot of things. Still we are not really reliable and robust. We're testing it around, but that I am pretty sure that cost will come down over time. And today, whatever is 80,000, I'm pretty sure it will come down to 50,000 in the next cycle. So these three are the most important factors. If you go further, there are huge opportunities in farm mechanization, or what I call as a farm robotics. We need to build robotic platforms, a row type crop, or like what the mission I've done is a row type crop. We need similar machines for the orchard, we need for the greenhouse, we need for the hilly terrain. Each one of them has, if you start looking at it in detail, they have a huge challenges which are very different. Like if you hilly terrain, you can't build a easy vehicle there. You can't run a tractor on a hilly terrain, right? The row type tractor machine which I am doing, it goes over the crop, right? So I can't use a normal normal tractor to take my robotic arm. So I need a machine which is over the crop, and the height of the crop puts a lot of challenges in the machine, right? So if you are a mechanical engineer, you understand that there is no wheel-to-wheel axle at the axle, and so that itself makes a big difference to build a machine, right? And that's what we are done. And this kind of machine has to come in, and a lot of European companies are coming up with solutions for row type crops now. But come to orchards, we need a lot of different, because if you're talking about mango, maybe some 8 to 10, 12 feet, we need reachability. For a cotton, it's only reachability of 5.5 feet. If you take a orchard like mango, I think you might 8 to or maybe even 20 feet, right? If you take a coconut, it's going to be a lot of difference. So this orchard plantation requires a very different kind of a solution, different terrain. Greenhouse is very different. You can simplify the solution, but it's going to be different. And hilly terrain, in my opinion, is going to be the most challenging. We are we have a solution for tea garden. If anybody is interested, we can talk about it. And each of the crop requires a different kind of what's called as an actuator. We are doing for cotton. I cannot go and use that picking unit of the cotton for a tomato, or a tomato picking unit for a bendi. So this is all, each one of them has a very, very different challenge. Like our hands are so very dexterous and smart. Our fingers and hands are some of the best actuators we have. I don't think it's very easy to build something like that. And maybe we don't need to, right? For picking a tomato, for picking a cotton, I don't have to sense the softness. Whereas for picking a tomato, I need to do it, right? So each of them requires to be customized and has to be built. And so I'm just trying to say that there are huge opportunities, even for just an actuator, building an actuators. There are some technologies called soft actuators. Soft actuators are coming, and many mechanical engineering designs are coming. Right? If you look at tasks beyond harvesting, right? Weeding, you need to do something different. If you want to do what's called as pruning, pruning is basically cutting, but how do you cut? Where do you cut? It's very different. If you're talking about leaf cutting, for example, tobacco or tea, that is going to be very different. So each of this have a different kind of interesting technology challenges and cost challenges also. And last but not least, we are in a world of artificial intelligence. We can exploit it for a whole lot of important work in the farming. Scouting is one of the important tasks a farmer has to do. You are supposed to be the best scouting person. You have to be in the farm at 7 in the morning or before the sun rises to figure out how good is the crop, whether it is having pest or disease or nutrition deficiency or whatever, moisture deficiency, whatever. That's called scouting. And technologies are there to now today to do that. And artificial intelligence is one of the best technologies available, which can do a lot of scouting. Many of you in the seed industry know what is called as plant phenotyping. We can do plant phenotyping also. Crop health prediction is a thing, and yield estimation. So a lot of this technology which coming up today using drones or even mobile robots can benefit using artificial intelligence. And for students there here coming up, there is a huge opportunity because every crop requires a very different solution, and every task in every crop requires a different solution. And what works in bendi will not work in brinjal, right? So, and what works for chili will not work for cotton. So there is a huge opportunity existing even in the Indian context, right? But the problems are exactly the same across the world, except that the terrain is different, the scale is different, right? But the technology solutions are the fundamental technology solutions. If you can build something in India which works in India, you can build it for the world. And good wishes to everybody. And thanks for this good opportunity. Bye.